Hello everyone, so today I'm going to be talking about my 4-bit to 1-wire encoder and also my 4-bit or 1-wire to 4-bit decoder. Now, these are not necessarily new designs from what other YouTubers have done, but the decoder specifically, I have a lot of extra filtering circuits that I haven't really seen done previously, and these circuits really help out my situation. I'm trying to make computer components that work as quickly and reliably as possible, and I basically just want to make it so that I can copy this whole thing and paste a whole bunch of them together, or make components all together and just connect each of them together with one wire. Anyway, I don't know if that made sense. So the encoder. So we got our 4-signal input here. Right now I just have some switches, but this applies for any signal that you want to put into here. So let me go ahead and clear that over there. So on this side, what we have is we have a line of repeaters. So we have this first repeater right here, and then we have a signal that is always on going into or right behind this first repeater. Now we call this the pilot signal. And the way that I set this up is I have a comparator here and a repeater. Now if you have a comparator and you have this little front light lit like that, what it does is it subtracts the redstone strength from the side from the redstone strength from the front. So we have a 15 signal strength here, 15 signal strength here. There is 0 data going out, and that's how we want it to be. Then when we submit it, all this does is it turns off the torch, which releases this signal. So then we have a 15 signal strength minus 0 is a 15 signal strength out, going through this block and then into the to the 1 wire. Now, this concept we just repeated. This is a 4-bit encoder, so as you can see, we have 4 little sections back there, well 5 technically, and I'll explain that 5th one here. So we're calling this the pilot signal. I don't know if I already said that, but this is a constant signal. Every packet of data that we send is going to start with a 1, and like I said, we call that the pilot signal. That goes out to the decoder, and the pilot signal basically goes through this filter here, and it tells the decoder, okay, time to start listening for a signal. So we'll do this here. Okay. Okay, so what I've done here is I've frozen the tick cycle. So we've activated these 2 inputs here so that we turn on these center 2 lights. Press the button that activates. That, like I said, turns off the repeaters, sends the signal through the comparator. This is a 1-tick generator. We just put this here because, again, we were having some issues with the game glitching, with how fast we were wanting to operate this, and we found out that doing this fixed that. I don't fully understand why, but it fixed it. So as you can see, this is what the encoded signal looks like. So we got if on this side you have a 0, 1, 1, 0, on this side what it looks like is a 1, 0, 1, 1, 0, but what it actually is pilot signal, which is start listening 0, 1, 1, 0. So yeah, I'll show you here. So And by the way, I have all these repeaters set to 2 ticks. We found that that's really the fastest you can go. We tried to do 1 tick, and we're still trying to figure out 1 tick, but our knowledge is not quite there yet. Anyway, so we'll keep stepping here so you can see the signal is traveling down. The pilot signal hits the decoder here. So we'll step it here. You can see that lights up. And then I'll show you, I guess, where the signal is going here. So the signal comes in and it gets split into 2 sections here. So this is where the pilot signal is designed to go. It's also designed to go down this section here, but I'll show you here in a second. So signal goes down through these comparators, and I have these comparators here because the intention is that it goes to here, activates the comparators through the side, again subtracting the signal strength so that only 1 tick comes through here, and it does not matter what any of the rest of the information is. It gets deleted by the pilot signal. So then past this point, all you have is just a pilot signal, and it goes into here, it goes into this repeater, through this comparator, and then cycles around, and it locks all of those repeaters back there. Now, it also sends a signal out here just to clear the last bit, because this clears the first 3, and then it sends one last little pulse to clear the 4th one there. Anywho, yeah, so this direction, this is where the actual data travels down. So you can see this center line here. Just goes all the way through to the back. So I'll show you guys how this signal travels through the system. Okay, so you can see it just deleted that signal there. It's traveling through. So now at this point, this activates all of these repeaters to lock. They're not locked yet because we have to go a couple more ticks, but I'll show you here. Boom, repeater's locked. So now in this position, this is only a momentary operation. So the data is in its correct position, it's synced up, the pilot signal hits its trigger, and that triggers everything to capture the signal going into this. Now we have the signal going out, and I could not figure out why, but for some reason the signal going out was not quite stable enough for everything else we wanted to do, and I don't know why, but I understand it has something to do with how Redstone ticks work versus the actual game tick. That's all I know, though. I don't know the actual specifics. I just know that it's related to the Redstone tick versus the game tick. So here's my solution to that. We have another effectively filter type thing that has locking repeaters. So all these repeaters are locked. You can see the correct signal is here. So we take the next step. Now all these repeaters unlock, accepts the signal, locks back up. So now we have this stored, and we can do whatever we want with it past this. So yeah, like I was saying, this is kind of complicated here. Trying to think of the best way I can explain this. So anyway, yeah, when the signal comes in here, the pilot signal goes down here, and like I said, this filters that signal, sends just the pilot signal down here. Oh, I forgot to show you this. So the pilot signal comes down this register and then into this comparator, and this comparator then resets that signal right there. So that then unlocks these repeaters after these ones have locked and captured the signal, and then it just continues on as if nothing happened. Now, I don't know how comfortable I feel about taking the data that comes out of here, just because it seemed unreliable going out that way, so I'm not sure if it would be unreliable going out this way as well. I don't see why. Oh wait, wrong spot, I meant right there. I don't see why, because all these repeaters are timed exactly the same as the ones that are transmitting the data. You know what, theoretically it should be fine. I changed my mind, this should be fine. Anyway, I don't know if that made sense. Hopefully it did make sense, but if not, I'll make a revised video, hopefully explaining it a little bit better. Definitely leave some comments explaining to me how I could explain this better to you. Yeah, like and subscribe.